This is the majestic Firth of Forth outside Edinburgh. It's home to Scotland's biggest engineering project in a generation, the Queensferry crossing. And we're following every step of the process as this incredible structure begins to take shape. Last year, we saw how the engineers laid the bridge's foundations deep underwater. This is amazing! So how far down are we?
We are right now at minus 14, so 14 meters under the water level.
And over the past year, things have come a long way. But now the engineers face another challenge. While the main towers out there are well underway, what they have to do next is to connect the bridge that will eventually be on those towers to the shoreline here. And this is what they're using to do it. These 3,000-ton viaducts will connect the road on land to the deck of the bridge. They're so heavy that they need to be supported by 8 concrete piers. And the man in charge of this huge operation is lead engineer Chris Higgins. So Chris, talk me through this bridge of yours.
Okay, so the bridge is made up of 2 main sections, the approach viaduct and the main cable stay section. What we're doing at the moment is we're constructing the approach viaduct, which leads from the access roads onto the main cable stay bridge.
These massive structures need to stretch over 500 metres from the shore out to where the deck of the bridge will begin. And that's not all. These viaducts need to be very carefully balanced. If anything were to go wrong though, I certainly would not want to be stood here if it did. So how on earth do you move something this big suspended up in the air half a kilometre out over water? The key to getting this whole operation right lies in these rather unassuming cables. So, Chris, what's the big deal with these cables then?
These are the cables that lift up the end of the deck to keep the deck level as we're launching over the piers. If we didn't control the level of the deck, essentially what would happen when we got to the next pier is that the deck would knock over the pier.
So, to avoid a disaster of monumental proportions, Chris and the team are relying on some deceptively simple physics. Imagine that this is my version of what's going on behind me, although granted this is a slightly less technical version. Imagine that this lump here, this is my viaduct. As the viaduct is pushed outwards, the front begins to sag under its own weight. If it dips too much, it could knock over the pier. So what they do is they attach steel cables to the front of the viaduct, and then they put in what's known as the king post, and you can see that behind me. It's this thing sticking up here. With a bit of tension on the cable, the engineers can lift the front of the viaduct so it doesn't catch the pier and makes it safely across. And that is very important when you've got a £1.4 billion engineering project. The viaduct is pushed outwards in 90-metre sections, each one reaching the next pier. But it's not a quick process. At a top speed of just 6 metres per hour, it takes over 8 months to reach the point where the viaduct ends and the deck of the bridge begins. And once they've finished on this side, they have to do the whole thing all over again on the opposite shore. So how much further have you got to go in this direction?
So we've got another 300 metres to launch. We've got 2 more piers to build, and we plan to have that complete by Christmas time.
So you've got a bit of work left?
Bit of work left to do. Once we've done that, we've then got to come back and start casting the deck on which the vehicles are going to run.
Wow, look at that, what a bridge. We are now joined, I'm very, very excited to say, we're joined by one of the most stylish